Okay, in this section, we would like to talk about the atoms. Okay, uh, the first thing we like to discuss elements in more details. Okay, elements is the pure, simplest substance, or pure simplest substance that cannot be further divided chemically. Okay, elements are made of only one type of atoms with the same atomic number. Okay, prime number. Okay, that's the elements. The definition of element. Uh, Elements can be classified as metals, non-metals, and metalloids. Okay. Metals are good conductors, okay, of heat and electricity. Okay. Also, they are malleable and ductile. Malleable means they can hammer into sheets. Okay. And ductile means they can draw into a wire. Okay. That's two physical properties. Most of metals are solid at room temperature with a characteristic silvery shine. Okay, except for mercury. Mercury is a liquid. Okay, that's the metals. Okay, non-metals. Non-metals usually are poor conductors of heat and electricity, and no malleable, not malleable and ductile. Okay, many of elemental non-metals are gases at room temperature, and some others are liquids, and some are solids. Okay, the non-metals can be a gas, liquid, and solid. Okay, so we know that the matter has three phases. Okay, non-metals can be one of them, three phases. Okay, gas, liquid, and solid. Okay. Also, we have one classification of element is called metalloids. Metalloids are intermediate in their properties. Okay, it's between metals and non-metals. Okay, in its physical properties, they are more like non-metals actually. Okay, but under certain circumstances, several of them, several metalloids can be made of can be made of conducting electricities. We call the semiconductor. Okay. Okay, semiconductor extremely important in computer, in making computers and other electronic devices. Okay, here this is a kind of a periodic table, and we just it's a simple one. Just show you the locations of those three type of elements: the metal, non-metal, and metalloid. Okay, you can see the red color. It's a larger area. It's this is area for metals. Okay, in periodic table, and you can see this blue colored on the right side. It's non-metals except the hydrogen here. Okay, and the yellow colored elements in red background, in yellow background, metalloids, or metalloids. Okay, they have the properties between metal and non-metal. Okay, that's the locations of those three different elements on periodic table. Okay. So next is it's a compound. Okay. Compound is a pure substance formed by chemically, okay, combining two or more elements together. Okay, chemically combine two or more elements together is a compounds. Okay, a chemical formula of a compound using element symbols. Okay, like these element symbols to show the identity of elements forming the compound, and subscripts to show the ratio of atoms contained in the compound. Here is some examples. Okay, and you can see it's water. The H hydrogen, there's a element symbol, and this subscript is 2 here. It means 2 hydrogen, and oxygen. Okay, if there's no subscript, that means only 1 oxygen here. Okay, if it's only 1 atom, you don't have to write 1 here. Just don't write a subscript if it has no subscript under the element symbol. That means only one atom. The second example is the carbon dioxide. Okay, you can see the 1 carbon and the 2 oxygen. Okay, and of course this is the glucose, and made of 6 carbon, 12 hydrogen, and 6 oxygen. Okay, that's the compound. Okay, so the atom has a structure. Let's take a look at the structure of an atoms. Okay, and you can this simple table here. Okay, an atom made of 3 particles. Okay, one is called proton, one is called electron, and one is called neutron. Okay, and the symbols, proton is a small p, and electron small e, and neutron small n. Okay, the mass. Okay, we like to introduce the new unit is called AMU. AMU is the number of protons. No, AMU is signed to be 1 of 12 of the carbon atom. Okay, it's the AMU called atomic mass unit. Okay, proton has 1 AMU. Electron has 0. Basically has no mass, and the neutron has 1. Okay, and next is you can see the charges. Okay, proton has 1 positive charge, electron has 1 negative charge, neutron has no charge. Okay, okay, next is atomic mass. Okay, atomic mass is the number of protons and the neutrons, okay, for given element. Okay, because these 3 particles, only proton and neutron has a mass. Okay, so atomic mass is the number of the proton and the number of neutron for given element. Okay. We just talked about this unit, atomic mass unit. is assigned to be one of 12 of a carbon atom. So the carbon atom has a mass of 12. Okay, if we convert into a gram, 1 AMU equal 1.661 multiplied by 10 to minus 24. Okay, it's a very, very small unit. Okay, very small. Okay. Protons and neutrons form nucleus. Okay. Electrons form electron clouds surrounding the nucleus. Okay, that's the locations of those three particles in atom. Okay. Next is a very important concept is called atomic number. Okay, the symbol for atomic number is capital Z. Okay, atomic number is the number of protons of an element. Okay, a given element has a unique atomic number. Okay, the atomic number cannot be changed for a given element. If you change atomic number, you change the element. Okay, for example, hydrogen has atomic number 1. Iron has atomic number 26. Okay. Atomic number is the product number, so atomic number, product number, and the electron number are the same for any neutral element. Remember, it's neutral elements. Okay. All right. And briefly, let's take a look at this nuclear reaction change. Nuclear reaction means changing the atomic number. Okay, the element come from the changes changes in atomic number. Elements, okay, convert to another element. Okay, nuclear reactions change atomic number, converting one element into another. Okay, if this is don't get confused. This is a nuclear reaction, not chemical reactions. Chemical reactions cannot change atomic number. Okay, only nuclear reactions can change atomic number. Okay, nuclear reactions release nuclear energy. Okay, we know that atomic bomb. Okay. You can see this equation here. It's called a beta emission, and C14, and release one electron become the nitrogen 14. Okay, the C carbon has 6 proton. This is mass number 14. This 6 here is atomic number. Okay. From here you can see the carbon 14 has 6 protons and 8 neutrons. Okay. Total mass is 14. Okay. Once this carbon 14 release 1 electrons, they convert into nitrogen. The nitrogen has 7 protons. Okay, has 1 proton increase. Okay, because once this lose the 1 electron, 1 neutron in carbon, and convert into a proton. That's why the proton number changes. Okay, the mass still the same. Okay, so just 1 charge difference. Release a negative charge. Okay, release a negative charge. So the nitrogen has 1 positive charge more than carbon. Okay, 7 protons. This is 6 proton. All right, this is the nuclear reaction difference. You can see the difference between chemical reaction and the nuclear reaction. Okay, the last concept here with is isotopes. Okay, atoms of the same elements have a different number of neutrons. Okay, the element cannot change protons. Okay, if you change protons, the element changed. It's not that element anymore. But an element can have a different number of neutrons, so they can be different in mass. Okay, most elements are a mixture of isotopes. Okay, isotopes is just elements have the same proton number but different neutron numbers. Those are forms of an element of a given element are called isotopes. Okay, isotopes are the forms of an element which has the same proton number but different neutron numbers. Okay, different mass. Has the same atomic number but has a different atomic mass number. Okay, because isotopes have a different number of neutrons, so they have different atomic masses. Okay, atomic masses of elements on the periodic table actually are the average mass of isotopes. Okay, in nature. Okay, they calculated based on the proportion of isotope mixture in nature. Okay, you can see that's why you can see the mass of those elements on periodic table has a decimal point because that masses take an average of all the isotopes. Okay, let's take a look at the example of chlorine and chlorine 35 and chlorine 37. Okay, two isotopes chlorine. One is 35, one is 37. They all have a same atomic number, but have a different mass number. That means this 35 has 17 protons and 18 neutrons, and this one has the proton number says still the same, has 17 protons and 20 neutrons. Okay, the isotopes of an element has the same atomic number but different mass number, atomic mass number, and different mass number, different neutron number, and different mass number. All right, that's the topic about atoms.